Welcome to the deep dive. Today we're digging into your research on something called Adaptive Bitrate Streaming, or ABR, basically the tech that stops your videos from buffering all the time. Our mission really is to unpack this unsung hero because, it's always puzzled me. Why does streaming sometimes work flawlessly when I'm on, shaky train Wi-Fi, but then at home, with decent internet, it suddenly gets all pixelated?
Yeah, that's the classic question, isn't it? And the answer, almost always, is AVR doing its job. It's arguably the most crucial tech for modern streaming. The core idea to grasp is this. AVR is designed, first and foremost, to keep the video playing. Continuous playback beats perfect quality every time. That's its programming.
Okay, so playback over picture quality, how does it actually manage that? You mentioned an analogy in the notes, like a GPS.
It's exactly, yeah. Yeah. Think of AVR as this really smart GPS for your video stream, your internet connection. That's a highway. And this highway has multiple lanes. You've got the super fast 4K lane, a solid HD lane, maybe even a slower 240p lane for really bad traffic. ABR is constantly checking the traffic conditions, that's your real-time bandwidth, and it automatically switches your video stream into the best possible lane to keep things moving smoothly. No buffering.
Right, switching lanes makes sense,
Yeah.
but the video needs to be ready for those different lanes, right? It can't just magically transform on the fly. How is that preparation handled?
Good question. That preparation phase is absolutely critical and happens way before you hit play. First step is creating what we call the bitrate ladder.
Hmm.
When a streaming service gets a movie or a show, they don't just store one version. They transcode it. Think of it like recooking it into multiple versions.
Mhm.
You get these massive high-quality 4K files at the top using a high bitrate, then maybe 1080p, 720p, all the way down to tiny, super compressed files like 240p using very low bitrates. That whole stack of options, that's the ladder.
Wow, okay, so every show is potentially dozens of different video files just sitting there waiting.
Pretty much, yeah. And then the next step. Each one of those versions on the ladder gets sliced up. They cut it into small, manageable pieces, usually somewhere between, say, 2 and 10 seconds long. These are called chunks.
Chunks, got it, little video segments.
Exactly. So you'd have chunk #1 in 4K, chunk #1 in 1080p, chunk #1 in 480p, and so on for the entire video. And the final prep piece is the manifest file. Think of it like a menu. It's a small text file, usually in a format like HLS or MPEG-DASH. This menu lists all the available bitrate ladders and, crucially, the web address, the URL for every single chunk of video.
Right. Okay, this is interesting. One of the key things that jumped out from the research was that the big server holding all this stuff, it's actually kind of dumb.
Huh. Well, maybe passive is a better word. But yeah, that's a really important distinction. The server just holds the files and the manifest. All the intelligence, the real brain of the ABR operation, is the video player on your device. Your phone, your smart TV, your laptop.
Right.
That's where the decisions happen.
Right, so the player gets the menu first.
Yep, downloads the manifest. Then immediately it checks your current internet speed right now. And based on that speed, it makes its first order. It might say, okay, speed looks great. Let's grab chunk #1 in 4K.
And while that first chunk is downloading and starting to play, it's already thinking about the next one.
Constantly. It's in this continuous loop. Check the speed, order the next chunk, play the current chunk, check, order, play. So if your connection suddenly dips, maybe someone else starts a huge download, or you move to a spot with weaker Wi-Fi.
Yeah, happens all the time.
The player detects that drop almost instantly. And it adjusts the next order. It thinks, uh-oh, traffic jam, better order chunk #2 in 1080p instead of 4K.
Yeah.
It's always trying to stay ahead, always trying to keep a few seconds of video ready in its buffer so it never runs dry.
So that occasional blurriness or pixelation we see, that's not actually a failure. That's the system working.
Precisely. That's the trade-off. ABR is built on this principle of acceptable compromise. A temporary drop in visual quality is far preferable to the stream stopping completely. Seeing the resolution dip for a second or two and then maybe recover? That's ABR, successfully navigating a tricky patch of internet traffic to avoid that dreaded spinning wheel. It proves we'd rather watch something than nothing at all.
Okay, so summing it up, ABR is this smart system. It relies on videos being pre-prepared into multiple quality chunks arranged in ladders. And then your device's player acts like a conductor, constantly checking your internet speed and ordering the best possible chunk for that exact moment, prioritizing smooth playback above all else.
Got it. It's this constant real-time negotiation.
So maybe the final thought for you listening is this. The next time your video stream flickers or looks a bit blocky for a moment before clearing up,
Don't get annoyed. Maybe take a second to appreciate it. You're actually witnessing a really complex high-speed dance between your device and the global network, all just to make sure the show goes on. Pretty cool when you think about it.